All right, well, today we are going to start chapter 11, which is a fairly difficult chapter. It's stuff you haven't really ever seen before, haven't done much with. So make sure you go print these notes and take good notes while we're watching this video. So here we go. So what are we working on? We're working on radicals, and also we're working on rational exponents. And what rational exponents are is those are fraction exponents. So we're going to be working all chapter with radicals. These are these root things. You've seen those before. And then we're also going to look at fraction exponents, which again are called rational exponents. So we got to be able to work with them. You got to be able to simplify them. Not the easiest thing to do. So before I start this lesson, though, I wanted to take a minute to review a few roots that you should know. So let's go through a list of cube roots that you should know. Okay, so cube roots, you should know the cube root of 8 is 2. You should know the cube root of 27, that's 3. You should know the cube root of 64, that's 4. The cube root of 125 is 5. And the cube root of 216, and that is 6. Okay, you should know those cube roots. There's obviously others, but those are the ones that kind of should pop in your head. You're going to see those often. Okay, some fourth roots you should know. You should know the fourth root of 16. That's 2. You should know the fourth root of 81. That's going to be 3. And another one that comes up often is the fourth root of 625, which is 5. Obviously, there's others, but these are kind of the main ones to make sure that you know. All of your square roots, we've gone through square roots many times. You know all of those. Okay, so a little bit of vocabulary for you. So if you have the cube root of 27, 3 is called the index. Okay, you're going to hear me say index quite a bit in this chapter. 27 is what is called the radicand. Okay, now I'm going to tell you right now, you'll probably never hear me call it the radicand again. But the number inside the root is called the radicand. But what we do need to know is this number that we put, so anytime I write a radical and I put like a 5 in here, that means that it's a fifth root. That's the index. The index is 5. Now, you need to know that square root does not have an index. Okay, you don't write the 2, although you can. It's an implied index. So if there is no 2 there, you know that it's a square root. Now, what is the importance of that number? Well, that's going to tell us the group size, the number of things multiplied together, the same number, to make that. Okay, so looking at example number 1, this is a square root. We're looking for 2 numbers multiplied together, the same 2 numbers, to make 16. Well, 4 times 4, so the square root of 16 is 4. We already knew that. Okay. The fourth root of 81, we're looking for something multiplied by itself 4 times to make 81. That'd be 3, and the negative is sitting out front. So the answer there is negative 3. Now, sixth root of 18, you're looking for groups of 6. This is where it gets a little bit confusing for kids, so we'll be working a lot on this. But this, with letters, is your group size. So you're looking for groups of 6. Now, how many groups of 6 are there in 18? There's 3. 6 goes into 18 3 times. So that gives us an x cubed for our answer. That's a little tricky. We got some work to do on that. Cube root of 125, so we're looking for 3 things that multiply together to make 125. That would be 5. Okay, 5 times 5 times 5. Now, you can odd index a negative. You can't even index a negative. We've had i's and stuff like that before. But if it's an odd index, you can root a negative. Because negative 5 times negative 5 times negative 5 would be negative 125. Okay, coming back to this letter here, Group size of 9. How many groups of 9 are there in 27? It's like you divide it in there. It goes in there 3 times. So x cubed is going to be my answer. Again, we got a lot of work to getting that to where we understand it. One of the main things we're trying to do today is we're trying to understand that a rational exponent, a fraction exponent, is the same thing as a radical. Okay, so this is very, very important that you understand this. Okay, that when I have a fraction exponent, let's say, for example, x to the 2/3. Okay, based on this rule, the bottom of the fraction, the denominator, is the index for the radical. Okay, so again, the bottom of the fraction is the index for the radical of x squared. Now, you may decide, and this is where you need more experience, you may decide to put the squared inside, but you can also write this as the cube root of x squared. A lot of times you'll do this way because you'll know the cube root of the number before, and then it's easier to square it after. I will show you these, don't worry. But the idea is that the bottom of the fraction is your index. Okay, and then this top number is your exponent. You can either put it inside or put parentheses around the whole thing and put it outside. So let's look at a couple of those. Let's say that you had x to the 3/5. You could make that the 5th root of x cubed, or the 5th root of x cubed. That would be fine. Okay. Now you can also go the other way. I might give you the 7th root of x squared, and then you can rewrite that as a fraction exponent, x to the 2/7. Okay, so I can write radicals as fraction exponents as radicals. So we're going to try to do that now. So let's jump into this. So this is evaluating rational powers. You may want to change to a radical. Again, at this point, I don't really understand fraction exponents. I can do radicals. I can square root things. I can cube root things. I can 4th root things. So I'm going to take something like this, and I'm going to rewrite it. I'm going to rewrite it as the cube root, because again, the bottom of the fraction goes to the index, of 27. And now I have my option of where I want to put that 2. If I put the 2 inside, I'll have to square 27 first. Well, first of all, do you even know what 27 squared is? Probably not. Okay? So I'd be better off to put it outside. And why I would do that is because now I can do the cube root of 27. That's 3. And 3 squared is 9. Okay, again, if I do 27 squared inside here, I'm going to struggle with that. I probably won't get it very easy. All right, let's keep going. All right, so first off, any negative exponent drops to the bottoms. This is 1 over 125 to the positive 4/3. Now we're going to work on simplifying that bottom. So it's going to be, I'm going to rewrite it as a radical because I understand that better. So the bottom is the index, cube root of 125 to the 4th. Well, the cube root of 125 is 5. So we get 1 over 5 to the 4th. And 5 to the 4th, 5 times 5 times 5 times 5 is 625. So this is 1 over 625. There's our answer. Okay, let's keep going. Next one. Okay, again, rewrite as a radical. This is going to be the 5th root of 32 squared. Again, I like to try to put the squared outside because otherwise then I got to do 32 squared first. Now, is there a number that I multiply by itself 5 times that makes 32? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. The 5th root of 32 is 2, and 2 squared is 4. Okay, so far so easy, not too bad. Okay, let's try letter D. Letter D, we're going to write this as 1 over 64 to the 2/3. Okay, the negative exponent drops to the bottom. Now I'm going to try to rewrite it as a radical. the cube root of 64 squared. So the cube root of 64 is 4, and 4 squared is 16. And there's our answer. Okay? All right, now we come down here, and they want us to simplify, then write it using a radical. Meaning we got to put this together. So we're going to use exponent rules to do that. Exponents say that if we're multiplying with the same base, we can add the exponents. X to the 4/5. Okay, so I just added the exponents, 1/5 plus 3/5. And now I'm going to rewrite as a radical, the 5th root of x to the 4th. And there's our answer. Okay, we rewrote our fraction exponent as a radical. Same thing on letter B. We're going to add the exponents, y to the 6/7. 2/7 plus 4/7 makes 6/7. And now we're going to rewrite with a radical the 7th root of y to the 6th. And there's our answer. Now, power to a power, you multiply the exponents. And I'm going to leave them with a common denominator here. So I'm going to actually make this m to the 2/4. I'm just multiplying 2 times 1/4. N to the 3/4. I'm not going to reduce that. And the reason that I'm not going to reduce it is because I can write it then as one radical with an index of 4. They're both the same bottom, index of 4. M squared n cubed. Okay, again, you just write the m's with their top exponent, n's with their top exponent. You'll notice with all the letters I've been putting the exponent inside, and you should do that too. It's with numbers, usually like what we had above, that you want to put it outside. Okay, letter D here. Let's apply the 1/8 power. We're going to have a to the 3/8. So you're just multiplying the exponents. C to the 5/8. And then that's going to give us the 8th root of a cubed c to the 5th. And that is going to be our answer. Okay, go take a little break. We got to get on to the next page and then come and watch the second video. All right, so take a break and then come back.